FINOW Rohrsysteme GmbH is located near the Oder-Havel Canal to the north of Berlin. FINOW Rohrsysteme has been affiliated with Kraftanlagen München GmbH since 2007. 100 years ago, the prefabrication of pipes for the power and the chemical industries began in Eberswalde-FINOW, situated next to the FINOW Canal. Even back then, Eberswalde was a hub of the metallurgical industry. The large company estate of today's FINOW Rohrsysteme GmbH offers the necessary conditions for the production of ready-to-assemble piping systems. In 1987, a new technological era was ushered in at our company. Three-dimensional bending of pipe spools became possible here thanks to applying a modern inductive bending machine. This Cogefex PB special program-controlled plant enables to bend pipes up to a diameter of 440 mm and a wall thickness of 70 mm. Multiple bending is also possible, as well as torsion between the individual bends. Inductive bending ensures decisive advantages as compared with conventional plain and pipe bends. A second and even bigger plant, our Cogefex PB1200R, started permanent operation in early 2007. The pressure slide exerts a feed force up to 1,750 kilonewtons and bending moments up to 3,000 kilonewton meters can be applied. The limit parameters are 1,220 millimeters in diameter and a wall thickness of 120 millimeters. Due to this, the FINOW Rohrsysteme company can cope with any current or envisaged future requirements of large power plant installations. Inductive bends are more than just a replacement of plain end pipe bends. The number of wells is reduced. Inductive bends are indispensable for highly stressed piping systems. They help increase quality and reduce cost. The pipe is clamped in the pressure slide and the bending beam. The inductor forms the primary winding of a transformer, and the pipe the short-circuited secondary winding. An electromagnetic alternating field induces strong eddy currents in the pipe. The pipe is thus heated up to 600 through 1200 degrees Celsius, depending on the type of material. The temperature is controlled in a non-contact manner and automatically kept within the set point range. The material is exclusively shaped in the heating zone. Cooling rings before and behind the bending zone ensure air or water cooling. The following are the main components of the IBM 1200 plant: combined slide with torsion support, bending beam with pipe clamp, inductor and cooling rings, pyrometers for measuring temperature, heating device, hydraulic block, control center. The pipe wall thickness within the tensile area is reduced by 5 to 20% through combined pipe feeding and kinematic force of the bending beam. An upsetting up to 60% occurs within the fiber and compression. Due to the eccentric arrangement of the inductor, the temperature of the pressure area can be increased in order to limit wall thickness reduction as well as the ovalization of the pipe cross-section. In the work preparation department, one of our engineers specifies the technological parameters for the pipe spool. The bending record sheet is put out on the CAD station. It contains all geometrical parameters of the component. The process parameters are checked for their reliability and optimized. A heat-resistant pipe of type P92 quality with an outer diameter of 590 mm and a wall thickness of 26 mm is inserted into the machine. The bending of a 54.1 degree angle is already completed. Now bending has to be performed at a 90 degree angle. The bending radius is equal to 1,700 millimeters. The operator adjusts the process parameters and starts up the plant. The ratio between the bending radius and the pipe diameter greatly affects the ovality of the bend. In this case, it is 2.8. The feeding is carried out at a rate of 8.0 through 9.5 millimeters per minute. The bending process has started. The heating unit is charged with about 250 kilowatt. The bending moment amounts to about 700 kilonewtons. At the selected feed rate, the actual bending process lasts 5 hours. The amount of feed is essential for the ovality of the bend. This is strictly specified, taking into account the long-term properties of the bend. The ovality shall be less than 2 to 4% of the pipe diameter. FINOW Rohrsysteme is able to achieve these values even with tiny ratio of R to D equal to 1.5. Depending on the material type and wall thickness, the pipe is heat-treated after its bending in the annealing furnace. The annealing parameters are also strictly specified and precisely recorded. Heat-resistant material is hardened at temperatures higher than 1000 degrees Celsius and subsequently tempered. The boundary dimensions of the bend are exactly measured. The finished spool is examined based on extensive non-destructive examinations. These include ultrasonic wall thickness measurement as well as magnaflux crack testing. Depending on the production standard and customers' requests, there will also be destructive tests carried out on material specimens from sample bands. They include, above all, tensile tests and notch impact bending tests at different temperatures. Metallographic tests serve for proving the correct metallurgical structure. Following the test and acceptance stages, the spool is then mechanically treated and finish processed. After sandblasting, an anti-corrosive coating is applied. Now the component is ready for dispatch. The application of induction bands instead of plain end pipe bands ensures decisive advantages. Improved quality and optimum load carrying capacity go hand in hand with cost savings in the assembly process. FINOW Rohrsysteme has gained more than 20 years of experience in induction bending and produces bends according to all relevant specifications and regulations. Based on our well-proven experience, as well as our staff's distinct quality awareness, FINOW Rohrsysteme supplies products of first-rate workmanship.